So in lab 6, we saw that we can connect our workbook to more than one data source. We connected our workbook to the union of 3 daily stock prices. We call that union Tesla. And we connected our workbook also to the quarterly S&P 500 financial results data set. We created sheets like the time plot that use the daily stock price information, and we created a sheet that used just the S&P 500 data, the quarterly data. We combined those two sheets in a dashboard. And what I'd like to do in this video is show you what happens if we try to use fields from both data sources in one sheet. How are those two data sources blended together? That's why this topic is called data blending. When we do data blending, one data source becomes the primary. It's the source whose field we drag into the view first, and the other one becomes secondary. And that can change from sheet to sheet. So in this case, let's start with the quarterly S&P 500 data as our primary source. And let's put together a table with year in the columns shelf, ticker in the rows shelf, and let's put average market cap into the table. So these are average market capitalization for each stock in each year. This is quarterly data. So behind this is average across the 4 quarterly market caps. Incredibly, Tesla's market capitalization on average in 2020 is 8 times that of GM. And that's why Elon Musk is the richest man in the world. Now let's see what happens if we try to bring in a field from the different data source, from that daily Tesla union. So let's take average closing price, and let's put it in there, and let's change the method of aggregation to average, and what do we see? Well, let's put the average price down. We see that average stock price for Ford is 10 in 2012, 10 in 2013, 10, 10, 10. That doesn't seem right. It's not certainly not constant across all the years. Why is that? What's happening? How is that 10 being calculated? Well, we have to really think how Tableau is connecting these two data sources. And we can see that Tableau is currently connecting the two data sources using ticker as the connector. And so it calculated a different average daily price for Ford, and different average daily price for GM, and different average daily price for Tesla. But it did not differentiate that average price across all the years, because it actually is currently not linking the two data sets on date, only on ticker. And that's why we see that there's a one linking field. There's another linking field that right now is that we're not using. If we want to change how the data is blended together, we can click on data and edit blend relationship. And we can select custom. And well, actually, I should because originally it's like this. So we're gonna select custom, and we're gonna add. We're gonna connect date to date. That's okay. And we're gonna add a ticker to ticker. And so now we're linking the two data sets using ticker and date. Automatically, originally, it just recognized linked it on ticker because those were common fields in the two data sets, but the date fields had different names. And so originally it did not link them because the stock quarterly data, the date is called calendar date, and in the daily price data, it's called date. But now we're linking them on both fields. So I'm going to say, okay. We're going to turn that link on. And now we see that our average stock price is indeed changing from a year to year. We see that Tesla's price is certainly rising from the average of 7 to the average of 364. Still, we want to think about what is that 364. How what is that averaged across? Is that averaged across the 250 observations that we have in 2020, or is it averaged across just the 4 observations that we have in 2020 in the quarterly data? Well, it is the latter. Because the S&P 500 data, the quarterly data, is the primary data source, and so it's only using the data points, dates in this case, that are present in the primary data source. We can verify that very quickly by taking that Tesla data, daily data, and let's put them in the table. Let's put ticker on rows. Let's make this an average. And let's really focus on just those last days of each quarter in 2020. So let's pick December 31st, September 30th, and July 30th, and then March 31st. Okay, and so if we use only those 4 dates and take average across those 4 stock prices on those 4 days in 2020, what do we get? We get 6.6. I guess let's change the formatting so we have it the average closing price down to 1 decimal space. Format number. Sure, we're gonna make it custom, just 1 decimal place. And we got 6.6, 29.3, 63.9, and I believe that's exactly what we get here. So which data set is primary, which data set is secondary, certainly matters. Again, when we're blending data with different levels of granularity, these are the kinds of things that we have to keep in mind. Can we turn this table into a nice line graph? Certainly we can. Let's duplicate it. Let's put our ticker on color. Let's put, how about we do this? Let's put measure values on rows. Yeah, there we go. And let's actually make these axes logarithmic. And oops. And this one, sure, actually both of them are now logarithmic. Fantastic. And so here we can see these are the average prices across the 4 end of quarter days. These are the market capitalizations. Tesla's climbing from 3 billion to about 400 billion on average in 2020. I think right now Tesla is at the end of 2020, so probably even higher than this. So I'll stop here.